In this video, we're going to talk about how we represent strings. Inside the computer, strings are represented as sequences of ones and zeros, just like numbers. A string is stored as a sequence of binary numbers, so one sequence of number per character. It doesn't matter what value is assigned to each character as long as it is done consistently. But in the early days of computers, each manufacturer used their own encoding for number characters. And later, we introduced the ASCII system, which stands for American Standard Code for Information Interchange, which standardized how we represent characters with numbers. Python uses another standard called Unicode, which is a lot bigger and represents almost every character in every language in anywhere in the world. However, ASCII is still a subset of Unicode. So here's an ASCII table where we can represent the uppercase letters with their corresponding codes or numerical numbers, the lowercase characters, and then next to their ASCII code or their decimal representations, and the symbols of number symbols, so 0 to 9, and this is how we represent. So, and you don't have to memorize this, but you need to be able to reference it whenever you need to. And this is not the complete list of ASCII table. We only see here the letters and numbers, and if you're interested, you can see the entire ASCII table. So here we could see the codes start from 0 to 127, so that's how many different characters we can represent in ASCII table. And the first 32 are not the print characters, they're meant for other purposes. And the very first one, 32, is space, so we represent space with 32. And then here where the number symbol starts, 0 to 9, and this is where the uppercase letters start from 62 all the way to 90 for capital Z, and we have some other characters in between the uppercase and lowercase letters, and the lowercase a starts with 97 and all the way down to 122. And notice that the delete character or the delete key is represented by 127. So now having both the uppercase and lowercase letters here, we can introduce the OR function. With the OR function, we can return the numeric or the ordinal code for a single character. And with the CHR function, we can convert a numeric code to the corresponding character. And here are some examples. So OR capital A will return 65, as you can compare from here, and the OR lowercase a will return 97. And with the CHR, so 97 will return the character A, and then 65 will return the character capital A. So let's see this in the Python shell. Now let's do some examples with the OR and CHR function. So OR first. So let's put in a character, let's say A, and we get 65 out. So since Python uses Unicode, so you can basically type any letter from your own native language if you have any as well, and then see the numeric value of it. So I'm going to, I can use non-alphanumeric characters as well, such as the question mark, such as the say the percent sign. They each have their own number representation. And with the CHR, I can put again, say 65, and I'll get the A, and I can use say 99, and that is lowercase c. Since Python uses Unicode, you can actually try to see numbers that beyond 127. So let's say I want to do, what is 200? 200 is this kind of accent E. Not sure which language it is, but let's say 210. I'll get this one. So there's an extended version of ASCII, which is ASCII 2. It goes all the way to 256, and the new ASCII represents all the characters in Latin languages as well. But if you go well beyond that, let's see what is 2000. Let's see if we hit or miss. 2000 is this symbol. Again, not sure what language it is. Let's say 3000. I got this one. Again, just making random numbers. Let's do 30,000. Here we go. So this is how we can use the ORD and then CHR function to check the Unicode characters or their numeric values.